Hi everyone, this is Swagat, and in this video I am going to explain about surface integral. So this is a part of vector calculus, and vector calculus is one of the most important topics in engineering mathematics. And this has many practical applications. For example, if we want to calculate magnetic flux coming out of a surface, we use this method. Suppose we have a vector point function f equals f1 I cap f2 j cap plus f3 k cap, and we want to integrate it over a surface. So let's take the three-dimensional picture. Now suppose we have a surface like this. This is the surface in 3D, and this is not contained in the YZ plane. So try to imagine it in 3D. So we take a small area element ds. Now we want to integrate over this entire surface. So this is the normal vector, normal unit vector to the surface S. So now what we can do is we have to project this small area element to either XY plane or YZ plane or ZX plane. So let's project it to XY plane. So this will look something like this. So this is the projected area. This is dx dy. Now so the normal to this is k cap. Now if we superimpose this ds on this will look something like this. Now this is the ds and this is our dx dy. So the angle between them will be the angle between the normals. So if this is theta, then this is also going to be theta. Now if this is the projected area dx dy and this is the actual area ds and this is the angle between them, which is theta, so we have a relation dx dy equals ds cos theta. Why? This is simply like resolving in one direction. Suppose this is our s, this is theta, so this will be s cos theta. Similarly, this is ds, this is dx dy, so this will be the relation between them. So we can write as ds equal to dx dy by cos theta. Okay, so now let's write the actual expression for this. F dot n cap ds over the surface S is equal to F dot n cap dx dy by cos theta. Now we have to find this cos theta. How do we find this? So we know the magnitude of n cap equals to 1, the magnitude of k cap equals to 1. So n cap dot k cap is equal to 1 into angle between them, cos theta, cosine of angle between them. So it implies that n cap dot k cap is equal to cos theta. So we can substitute this cos theta as the magnitude of n cap dot k cap. So the expression now becomes f dot n cap dx dy by n cap dot k cap. So this is the expression if we project in xy plane. Suppose we want to project on yz plane. So the expression will be f dot, so in yz plane if you are doing, so this n cap will be normal to the given surface, that is the actual surface, this surface. So now this dx dy, this will change into dy dz by n cap dot dy dz, means the normal to yz surface will be I cap. This will be the expression if we project on yz plane. So the final formula now becomes integration of f dot n cap ds over the surface S is equal to, S f dot n cap, and we are assuming that we are projecting it on xy plane, so dx dy by cap dot k cap. So this is now the formula. We can use this directly to find answer. So let's take an example. So the question is, evaluate So this is the question. Evaluate f dot n cap ds where f equals 18z I cap minus 12j cap plus 3y k cap. S is equal to, so the surface of the plane 2x plus 3y plus 6z equal to 12 in the first octant. So now let's draw the plane first. So this plane will be something like this. So where it will cut x-axis, so putting y and z 0 here, x equal to 6. Similarly, it will cut y-axis at 4 and z-axis at 2. These are the three intersection points, the x, y, z axis. Now the plane is given as 12 equals to 0. Okay, so this means, so how do we calculate the normal to any plane? How do we calculate n cap? So simply we take the gradient of phi, this will represent a normal vector, then we divide the gradient of phi by its magnitude, so we get, so this is n cap. So now let's calculate the gradient. This is basically let's calculate this for this plane. del phi by del x, this will be simply 2, del phi by del y 3, del phi by del z 6, 2i cap plus 3j cap plus 6k cap. So now n cap is equal to divided by magnitude of this, which is 2 square plus 3 square plus 6 square square root. By 7. So this is now the n cap. So now let's calculate ds. What is ds? ds is equal to dx dy by magnitude of n cap dot k cap. So what is n cap dot k cap? N cap is equal to this. So dot k cap. So simply all these terms will become 0. This 6 by 7 will remain. So is equal to 6 by 7. ds is equal to dx dy by 6 by 7. Now let's put it in the actual formula. F dot n cap ds over the surface S is equal to, so this is the question. What is F? 18z I cap minus 12j cap 3y k cap dot n cap. What is n cap? This is our n cap. F dot n cap ds. Now this ds, our ds is, so this 7 and the 7 get cancelled. So this is our final result. Now this has simply turned into a double integration. Here I have missed this 6. This is here, so this is 1 by 6. Now you have to solve this. Now this S has now changed. Previously it was S here. So this was the surface S, but we have projected it on XY plane. So our plane is now different. So this plane, if you project it on XY plane, so this becomes something like this. So this is now our area of integration. We have to integrate over this surface now. So now what we do, we will solve this. If we simplify this further, this becomes 1 by 6. We will take this as region R in the XY plane. We take out 6. So we can take out 18 directly from here. So this becomes 18 by 6, 2z minus 2 plus y. Dx dy. This is now 3. So then we see z is here, so we have to convert this z in terms of x and y. So we can do this from the plane of the equation. So this was our surface, so we will find the value of z in terms of x and y from here. So here's let's do it here. So we will put the value of z, this value here. So this will now become now what we can do, we can cancel this by 3. So now we have 3, 12 minus 2x minus 3y minus 6 plus 3y divided by 3 dx dy. So this 3 and 3 get cancelled, this 3y, this 3y get cancelled. Now this becomes 6 minus 2x. Now this is a simple problem of double integration. So now we have to find the limits of x and y. So how do you find the limit? So here if you see, we are now projected in x and y plane, so this will look something like this. So this is x, this is y. Now this will be the line. So how do you find the limits of x and y? We know this point is what this is called y, 4, and this is 6. So either we can take the value of x from 0 to 6, and we take the value of y from 0 to a function of x, or we can also take in this way. We can take the function of the value of y from 0 to 4 and the value of x in terms of y. So we will take the value of x from 0 to 6 and the value of y from 0 to, now we have to find the equation of this line. So simply we put z equal to 0 in this, the equation of plane. So we find the equation of line as, I am writing it here, 2x plus 3y is equal to 12. So it implies that y is equal to 12 minus 2x by 3. So we will put this as the upper limit of y. Now we have to solve this. Okay. So now let's solve this integral. This is the final step. So as we can see, the limit of y is given as this. So first we have to integrate with respect to y here. So let's do this. Six minus 2x dy. So this simply becomes 6 minus 2x. So dy is simply y, so we put this value as 12 minus 2x by 3. dx. Now we take out 2 from here, so 0 to 6, 2 is taken out, so this remains 3 minus x. Now we take out again 2 from here, so this becomes 6 minus x by 3. This is again 2, so this 3 is also taken out by 3 dx. Now we just simply multiply it, so this will become is x square minus 9x plus 18. Now we don't have to, so 4 by 3, x square is x cube by 3 minus 9x square by 2 plus 18x. Now we simply put the value of the limits in the place of x. I will not do any further calculation. So if we solve this, the final answer will be 24. So that's it. Thank you.